Hello guys, welcome to my YouTube channel Scholar Tech Studio. In this video, I will teach you how you can do a simple static structure analysis in ANSYS Workbench. If you will watch the video at end, you will know all the main key points that you must consider if you are going to do a static structure analysis, and like how you can prepare your geometry, how you can assign the materials, and how you can create high quality results that you can put in your report or your research article. Okay, so this is the interface of ANSYS Workbench. Here it has different analysis system. So here we have to select a static structural analysis. Okay, so we just need to drag this one here, or you can double click here and then it will be appear here. So the first option is engineering data. Okay, so if we will right click on it and then go to edit, so here you can see that the default material is static structural steel. Oh sorry, the default material is structured steel. Okay, so if you want to add another material, like if you want to do the structure analysis of aluminium instead of this structural steel, then how you can uh, like import the material from material library to your project. Okay, so for that, here you can see there is the option engineering data source. So here you can see there are different material types, and this is the current project directory. So it has the structure steel, and here you can see that if you this book sign, it means that this material is in our project. Okay, so here we can see, let's suppose I select like the granta material. If I select this one, and then here you can see that the material under this granta library are here. Okay, so you can, let's suppose you want to do a plastic high impact plastic material into your current project directory. So here you can see there is a plus sign, so you just need to click on it. Okay, and then you will go back to your uh, engineering data. Okay, and here you can see that now the plastic is added to our project. Okay, and then we go back to the project. So now we have specify our material, so this step is clear. So the next step is geometry. If we want to do a structure analysis, so we must have a geometry. Okay, so how, there is two options. One, you can create your geometry in ANSYS Workbench, or you can import your geometry into ANSYS Workbench. Okay, if you already have geometry, okay, you have created in other software like SolidWorks and other CAD software, then you can import that geometry into this geometry section. But in this video, I'm going to create the geometry using the design modeler of ANSYS Workbench. So in geometry, you just right click on it. Okay, and here you have three options: design modeler, space claim, and discovery. So these are three different option available where you can create your geometry. Let's suppose I want, or if you have geometry created in another software, then you can use this option. Okay, let me use this new design modeler. So it will take some time to open this one. Okay, so this is the interface of design modeler. So here you can see that there are three planes. Let's suppose I select XY plane, and then here you can find the option sketch. So then you need to click on the sketch. Now here you can see you are in sketch mode, and from here you can make it normal to the projection. Okay, and now under the sketching option, let's suppose I create a rectangle. So select rectangle, then here we have to specify the first and then the second end of the rectangle. Okay, and now we need to specify the dimensions. So under the dimension tool, we will select the vertical. So vertical will select this line and this line. Okay, and we also want to specify the length. So here for this we will select the horizontal. So we will specify this line and this line. So here you can see that this is the H and this is the V. Let's suppose we want to make it 100, and for this, no, 100, the units are in meter, so we can make it like 0.1 meter. Okay, and for vertical we will select 0.01 millimeter. Okay, so we can zoom this one, we can zoom this one. Okay, and now we have specify the height and the length. Now we need to specify the width. For that we will go to create, and then we will select extrude. Okay, so here we can see that we will select apply material, and here we have the option that is called by symmetric. If we will select this one, then it will create a symmetric extrude from both sides, and if we will select reverse, then it will extrude from that side, and if we will select asymmetric, then we can specify the extrude from this side and this side with different dimensions. Let's suppose I'm going to select the symmetric, so I want to make it 0.005. Okay, so now you can see it has created the solid body, and then we have just need to click on generate. So now you can see that our bar is created. Okay, and now we will just close this one, and now you can see that our geometric part is okay. And now we will go to the next part, that is model. Just right click on it and then go to edit. Okay, we have to wait. Okay, now this is the next step in the static structural analysis, and here you can see that our created geometry is here. Okay, so here geometry is okay. Okay, so let's suppose we want to under the geometry option, you can see this is the solid, and when we click on the solid, then here you can see that under the material section, the material is structure steel. If you want to do this analysis considering structure steel, then it's okay, but if you want to change from here, so here you can see that we have plastic that we added at the start, so we just select the plastic. Okay, and then go next option is mesh. Okay, so we just need to right click on it and then go to generate mesh. Okay, so the by default mesh is created, but if you want to increase or decrease the size of mesh, uh, then you can do. Okay, under the size option. Okay, so here you can see it's selected codes, so we can select fine. Okay, and then we will select and generate. Okay, so I think it's already fine mesh. It's not created, it not change its like the size. So we can specify the element size from here. Okay, let's suppose 0.00 or 0.1. Okay, and then, oh shit, here you can see that the units are in millimeter, but when we were doing creating this geometry, the units are in meter. So if they are millimeter, so this is very small. So we can select 10 millimeter. Okay, so 10 millimeter is okay. So we can change from here 10 is okay. So we have to check the units. So now it will create the parts of 10 millimeter, 10 millimeter, 10 millimeter. Okay, and then go to generate mesh. Okay, so the 10 millimeter is not enough, so we have to select 1 millimeter and then go to generate mesh. See, if you will decrease the size of mesh, then it will give you the accurate results, but it will take too much time to do the computation. Okay, so for this it's okay. And now the next step is we have to create our boundary condition. Like this is the cantilever beam, so we want to create a fixed support at the one end and we want to apply the force at the other end. So what we will do, under the static structure, we will right click on it and then go to insert and then go to the fixed support. Okay, so we will add this face. Okay, it's all, we already selected this one, therefore so we just can select this and then go to apply. So it's created the fixed support from here. Okay, and now we want to create force, downward force on this face. So what we will do, we will go to the structure and then we will go to the force. Okay, and then we will select this face. We will select this face and then from here we have to specify the, okay, so there are two options. From here we will select components. If we will select component, then we can apply the force in x, y and z direction. We want to apply the force in downward direction, so this is y. So we want to apply the force in opposite to y direction. Okay, so this is minus y. So what we will apply, let's suppose I apply minus 10,000 Newton force in downward direction. Okay, and so we have to select this face, not that face. So we have to select apply. Okay, now we have select this face, and for y and z it's 0. Okay, so now the next step, we have like what results we want from this one. So from here we want the total deformation, we want the strain, and we want to calculate the stress, and we want to calculate the factor of safety. So we will select this, so it has the factor of safety. Okay, and now we just need to solve this one. Okay, the deformation is very large. Okay, so this is the deformation. So because it's plastic and we apply too much load on this one, so here we can see that it's about the units are in millimeter and it's about 2000 millimeter deformation. So from here we can see the option is true scale. So here we can see that because the force is very large, so what we will do, we will decrease the force and then, okay, let's suppose we apply 100 Newton force and then we just need to change the force and just go to solve. so then it will update all the steps. Okay, so this is the deformation. Okay, so from here it's true scale, and this is our deformation, this is our stresses. Okay, and this is stress, and this is strain, and this is the factor of safety. So the factor of safety is 0.03, so it means that if we will use this material plastic, then this is not a stable. Okay, so here is the option contour. So here we can select the smooth. Now we can see that the contours are smooth, and from here we can select no wireframe, so then it will look like this one. But if you want wireframe, so then you can select the wireframe from here. Okay, so these are different options that you can select. Okay, so now from we can adjust the position of this one. Okay, position of this one. Okay, so if you will create, if you will take the screenshot of this one, then the quality of the video or quality of this picture is not good. So what we have to do, if we want a high quality picture, then what we can do, okay, let's suppose first I want the deformation. Okay, so what first we have to specify the orientation. Let's suppose I want to take the screenshot in this direction, and then we will go to the image, and under the image option we will select image from file or image to file. So we will select this one, image to file, and here we will select the high resolution, and here we will select the image and legends, and here we will select the white background. Okay, and then here we can select the 5 font magnification. Okay, and then said okay, and now we have to specify the path where we want to save this one, and from here we can specify the like name. This is deformation, and the file type is png, and said okay. And similarly I want this one, so we just select this one, go to image, import to file, and here we will select 5. Okay, and here we will specify the name like strain, and similarly for this one we will go to image to file 5, and this is stress, so we will select stress. Okay, and here is the factor of safety. We will go to the image, import file, and from here we will select the 5, and then for this we FOS, factor of safety. Now we will go to the desktop. Okay, now we will go to the desktop. We need to minimize this one. So if you see this, so this is the like the good quality of the results, and if you will put this in your report, then it's will looks good. So in this way you can create high quality output pictures to import put these picture into your report. I hope you like my video. Please subscribe my YouTube channel to get the notification of my upcoming video.